And we're back. So jumping back in with this composite figure right here, I really need to figure out what shapes I have, and then that's going to help me figure out what formulas to use, and then I'll be able to solve this problem. So if we were going to find the volume of this whole thing, I see it broken down into two different shapes. So I see this shape on the top, and then I see this shape on the bottom. So if you look at this shape on the top, it's not a pyramid. It doesn't come up to a single point. It has a lot of rectangles, which makes this a prism, and then this would be a triangular prism. So I'm going to go ahead, that base right there, this is our triangle. So this top shape, if it's a triangular prism, and I try to find the volume of a triangular prism, if we look at our formula chart, volume for a prism would be capital BH, just like that. Now remember that capital B stands for area of the base, and so this is where I need to be careful because my base is this triangle. How would we find capital B? How would we find the area of the base if the base is a triangle? Well, to find the area of the triangle, that would be 1/2 base times height. And remember in a triangle that the base and the height should make a T. So I have H, I know that that's 6.9. What I need is that base, which I can see right there is 8. So 1/2, 8 times 6.9, and that's going to tell me the area of the triangle. That's going to tell me that capital B. Remember that capital B stands for area of the base. So in a triangular prism, the base is a triangle. So I just need to find the area of that triangle, which is why I use this formula. And so now if we go to our calculator and we just figure out what that number is, that'd be 27.6. So capital B, so the area of our base is 27.6. So now I'm going to come back over here. So I know capital B, I know the area of the base, I know the area of the triangle, that was 27.6. What I need now is this H. Now remember that this H, remember these values are different than these values. This is just talking about the base, which is the triangle. So over here, this H is the distance from base to base. So asking yourself, what is the distance between the two triangles? What is the distance from base to base, from triangle to triangle? And if I look, what is that distance from triangle? How far apart are the triangles? This H is how far apart are the triangles? Well, I can see if this piece right here is the same as that piece, then they're 4 centimeters apart. So now I'm just going to figure out what that is. And that's the volume of my triangular prism, 110.4 centimeters cubed. Now, this wasn't just one shape, though. This was a composite, which means that this was two shapes. So now I need to find out the volume of the prism that I have on the bottom. And most of you are really familiar with that shape on the bottom. That's a rectangular prism. So to find the volume of a rectangular prism, it's the same formula as before, capital BH. What changes now is that when I go to find capital B, when I go to find the area of the base, well, for rectangular prisms, we can just always assume that the bottom, only rectangular prisms do this. But for rectangular prisms, I can assume that the bottom is the base. And so it's the bottom and the top now. And that's only for rectangular prisms. So rectangular prism, if my base is a rectangle, ask yourself, how do you find the area of a rectangle? Well, that would just be length times width. So if I look at that shaded rectangle, if I look at this base, that would be 8 times 4. And 8 times 4 makes that 32. So now as I come back over here, I know that the area of the base is 32. And remember that H stands for the distance from base to base. So how far apart is it from the bottom to the top? So how far apart is that? Well, from this base to that base, those are 5 centimeters apart. So 32 times 5 is 160 centimeters cubed. Now, I'm not done with this problem yet because remember I wanted the composite, which means that I want the total volume of the shape. So I have one more step. If I want to find the total volume, I need to add this piece and this piece. And if I add those together, then I get the total volume of this composite figure is 270.4 centimeters cubed. So as we look at composites, we really need to figure out what shapes do we have, what formulas are we going to use, would we add or subtract, And then just being very, very mindful whenever we're looking for capital B, which is the area of the base, and H, which is the distance from base to base. So taking a look at this next one, think of this like a paper towel roll or a toilet paper roll. It's really hard to tell from this picture, but asking yourself, what shapes do you have? Well, we have a cylinder, and think if it were a paper towel roll, then I have a cylinder taken out. So I have this cylinder, but then it has a hole in it. So if I'm going to find the volume, I'm going to give you a minute to think about how we would find the volume of this object. Well, we can see that there's two cylinders. So how do we find the volume? Like how much paper towel, how much roll is there? So that would be the big cylinder, and then I would take out that hole. I would take out that little cylinder. So I'm going to leave it in terms of pi. That's our default. So first I want to find the volume of the big cylinder. So I'm going to do that. So that way I'm clarifying which one I'm finding. So remember that volume of a cylinder is the same formula as a prism. It's just capital B H. And if it's a cylinder, asking yourself, how would you find the area of the base in a cylinder? Well, in a cylinder, the area of the base is a circle. So how would I find capital B? I would just do the area of a circle, which is pi r squared. So I'm going to do the big cylinder first, which has a radius. Notice its 18 is only pointing to the half, which is what I want. So I'm going to do pi times the radius, which is 18 squared. And if I leave it in terms of pi, that means I don't type pi in. So I would just type in 18 squared, which gives me 324 pi. Now that's the area of the base. I'm going to go back over here to figure out the volume. So the volume of it would be the area of the base, which we just found was that pretty big number, 324 pi times h, which is how tall it is. That would be 12. So now I need to figure out what is 324 times 12. And that would be 3,888, don't forget our pi, inches cubed. So I found the volume of that large cylinder. I used, remember the area of the base. The base was a circle because it's a cylinder. Found that, plugged it in, and then multiplied it by the height. Okay, that's the big cylinder. Now I'm going to find the little cylinder. So the volume of the little cylinder, it's the same formula as before. And because it's still a cylinder, to find capital B, or our area of our base, I'm still going to do pi r squared. But in this case, the radius is 9. So pi times 9 squared would be 81 pi. So now I'm going to come back over here to my volume formula. I just found the area of the base. Remember the area of the base was a circle, pi r squared. So that would be 81 pi. And h is still 12. If it's like a toilet paper roll or a paper towel roll, like it's the same height of the cylinders. It's the radius part that changes. So now I'm going to figure out what's 81 times 12. And so the volume of that would be 972 pi inches cubed. And now I have to think for a second. So I found the volume of the big cylinder, and then I found the volume of the little cylinder. But how would I just find the volume of the paper towel roll? Or the toilet paper roll? How would I just find the volume of that around part? Well, in order to do that, I would have to subtract in this case. If I have a hole, I'm subtracting. I wouldn't be adding a hole. If I have a hole, it means I need to take it out or subtract it. So if I subtract those two values, I'm going to get 2,916 pi centimeters cubed. Inches, my bad. I don't know why I've been saying centimeters. Inches cubed. And that would be the volume of the paper towel roll. Now, let's just say that they said round to the nearest tenth. So if you were told to round to the nearest tenth, you would need to take this and type it into the calculator using that pi key. And if you round it to the nearest tenth, which means you actually put pi in, we get 9,160.88, which would be 0.9. So this is rounded. It means I actually type pi into the calculator. And then in terms of pi, it's kind of the opposite of what you think. In terms of pi means we don't put pi into the calculator, we just write it. But if it's rounded, then I have to actually type it in. So it's a little bit backwards. In terms of pi means we don't actually type it into the calculator. Now, taking a look at this aquarium, I know the volume of the aquarium. The volume of the aquarium is 57,600, feet cubed, but I don't know how the height of it. I know how much water it holds. I know a few of its dimensions, but I don't know its height. So, asking ourselves, which shape is this? And then I'm going to have a formula and hopefully kind of go from there to help me out. Well, this is a box, so we don't call them a box in geometry. That we have a rectangular prism here. And because it's a prism, that means I know the volume formula is going to be capital BH, because it's a rectangular prism. And now what I want to do, before I have any numbers, I'm going backwards on this problem. So I have some numbers, but I don't have all of the numbers that I need. So I'm going to see, is there anything else that I can do to this formula before I plug in the numbers? So before I go backwards, is there any other information that I have? And that's capital B. If it's a rectangular prism, and you're going to find the area of the base, and it's a rectangular prism, then I'm going to go ahead and replace capital B with the length times the width, because that is how I find. Capital B stands for area of the base. If the base is a rectangle, ask yourself, how do you find the area of a rectangle? And that's length times width. So I'm going to take capital B and I'm going to replace it with length times width because I'm talking about a rectangle. So now my formula is going to be, instead of capital BH, it's going to be length times width times H. And you probably have seen that number before, or you've seen this formula before sometimes with rectangular prisms. So now I'm going to plug in everything that I know. So I know what the volume is. I know that the volume is 57,600. I know that the length is 120. And I know the width is 60, but I don't know the height. I don't know H. And it's okay if you flip the length and the width. It should still be the same. So if I were going to solve this, well, 120 times 60 would be 7,200. So I have 57,600 equals 120 times 60 would be 720H. And because I'm going backwards to find the height, I'm just going to go ahead and divide everything by 720. I'm going to give you a minute to go do that in the calculator, and that's going to tell us our height. So if you do that correctly, you should get that the height is 8 feet. Making this a kind of weird aquarium if you think about it. So like the depth and the width, it's like 120 feet long and like 60 feet wide, but then the depth, like it's only like 8 feet. So kind of a weird aquarium, not the best aquarium, but that's okay. We were able to take our volume and then work backwards to figure out that this is kind of a weird aquarium, but that's fine. So now taking a look at this last one, I have ice cream and I have two boys. So I have Bo and I have Blake. Now Bo gets a scoop of ice cream in a cone and Blake gets a scoop of ice cream in a cup. So Bo has the cone and Blake has the cup. Each container has a height of 8 centimeters and a radius of 4 centimeters. And each scoop of ice cream has an approximate volume of 268 centimeters cubed. So one scoop of ice cream is 268 centimeters cubed. If the ice cream melts, who would have the bigger mess on their hands? Now, I want you to think about this logically for a second because we actually don't need any numbers. If I look at this, I do know that the cone and the cup are the same height and they have the same width. They have the same radius. Each boy is getting the exact same amount of ice cream. It said each boy is going to get one scoop. So we just have to think who would have a bigger mess, meaning who would have more overflow, who would have more of a spill. Would the cone have more of a mess or would the cup have more of a mess? Think which one holds less, that creates the mess. Well, hopefully if you're thinking about this logically, the cone is smaller than the cylinder, meaning that Bo will have a bigger mess because Bo had the cone. So Bo will have a bigger mess, and if I asked you why, Bo will have a bigger mess, it will be because of the shape, right? It will be because he has the cone. But if we go take a look at those formulas, thinking of a cone formula over a cylinder formula, So if we take a look at the cone formula over the cylinder formula, the cone is a third of what the cylinder is, meaning that the cone can only hold a third of what the cylinder can hold. So because the cone only holds 1/3 of the cylinder amount. So the cone would only hold 1/3 of the cylinder's volume, which means that Bo would have a bigger mess. Now, it would be a different story if the cone was like taller or wider, but if they have the same height and they have like the same, like they're pretty much the same dimensions, one's just a cone and one's a cylinder, well, because the cone tapers in, it only holds 1/3. So if this cone could hold 40, the cup would hold 120. If the cup could hold 300, then the cone would only hold 100. So the cone would create a bigger mess, meaning that Bo would have more problems. That's it for volume. You're going to have the rest of the time to work on your practice. Good luck with that. Just be careful to remember what formula you're using and that capital B stands for area of the base. Good luck.